Here in the question, we are given that an alpha particle accelerated through v volts is fired towards the nucleus of an atom, and the closest distance of approach is r if a proton accelerated through same potential is fired towards same nucleus of the same atom, then closest distance of approach is r, 2r, r by 2, r by 4. So in the question, we are given that an alpha particle which is accelerated, which has been accelerated to v volts, which has been accelerated to v volts, is fired towards the nucleus of an atom which has a charge of, let's suppose it has a charge of Ze. Z for the number of proton and E the standard charge. So that's Ze, the total charge of the nucleus. Then the question is asking you, if instead of the alpha particle, if there was a proton and at the same voltage, and then it was fired at the same atom, and what it also here it was given that Ze was at the closest distance of approach as r, it's r0, suppose r0. Here it was given r0. Now you have to find how far this atom can penetrate, or how far it will be deflected, repelled actually, not deflected, repelled. So that's what the question is asking. So in order to answer this question, we all are aware that r0, the closest distance of approach, is equals to 2k QZD on mv square. This is derived through the law of energy conservation. But that's for another story. So now this is a general formula. This is not specifically for the alpha particle. It's a general formula. So now here, what we are going to do, we are not going to put the back, since we have to, if you are aware of, there is another formula, and that's half mv square is equals to, and kinetic energy is equals to qv. Q is here charge of the charge of the whatever atom is here, and V is the voltage. So if you see here, the question wants us to correlate these two formulas. If you look at the question closely, since we have to define it in V terms and we have given radius, let us do what it wants us to do. It can be solved in other ways too, but this works much better. Now a question to you: how can we express this formula in V terms? The answer is by replacing this mv square as a qv, right? Let's do this. Mv square can be written as 2qv, right? If we change it a little bit, it can be written as this. Now let's substitute this in here. So R0 will become, the numerator will stay same, 2kq ZE upon, and here mv square will become 2qv, V for voltage. Now if you see from here, now 2 will be cancelled from here and Q will charge will be cancelled, because if in the both of the formulas, the charge is of this particle which is fired, and that is why it will be same for both of these the formula at the end becomes R naught is equals to KZE upon V. Now you might be asking me, this is not the options which is given in the formula in the question. So why did we derive this new formula? The answer to that question is that if you look at this closely, here let me ask you a question. Why do in the general formula, here we have mass and here we have charge, which is different for these two particles. But if we cancel both of these, if both of these is removed from this formula, then the remaining you only have the K. K is a constant, Z atomic number, it is not changing. Charge of electron, that doesn't change either. V volts is also same. So R naught will be same for alpha particle and the proton. For both of them, this R naught will be same. So what will be the answer? The answer will be option number A, R, since it is also R distance. Hence, answer